So I'm just going to show you really quickly some work that was done about peer interactions and clickers. This was published in Science 2009 by a friend of mine, Michelle Smith and Jenny Knight, Bill Wood. Basically, their question was, does this active engagement of students during discussion with peers, some of whom know the correct answer, lead to increased conceptual understanding, like it did in this room, for example? We saw a shift towards D after a while. Or do students not, in fact, learn from the discussion, but simply just choose the answer most strongly supported by their neighbors? So if I had showed you the answer,
Yeah.
you may have gravitated to the wrong answer, for example, and then that would stick in your head. So anyways, they approached this problem, and I can't show you the whole study, but I'll show you something that they did because they were really interested in understanding peer discussion in classes. What they did is they gave students a clicker question, just like I gave you, and they responded, but they weren't showing the results. They got to talk to their neighbors and respond again to the same question, just like you did. This is how they performed after discussion. This was not just one question, by the way. This was published in Science, many, many questions. Then they were given what we call an isomorphic question. That means it's testing the same content, but it's not the same question. Students actually learned and taught each other through peer discussion. So this is one thing that they asked themselves, is it just for easy questions, or is it for more difficult questions like we just worked with? So they broke their questions down based on Bloom's. They found easy questions, these were the results. Medium questions, these were the results. And difficult questions. What you see here is that a certain percentage of students came in not knowing the concepts tested by these very difficult questions. Then talking with their peers, many more were able to answer the same question correctly. And look at their increased learning later on a new question. And the number of questions they did was not just one question.
Can I just ask the interval between question 1 and question 2? I mean, how long was it? And
I don't remember that, I'm sorry.
Yeah.
I'd have to go back to the paper.
Right.
Yeah. But I think the take-home message here is that peer instruction actually
Sure.
works. So let's give our students an opportunity to A, express what they're thinking around a topic, and B, get them to interact. They know more. Someone in the class knows a piece. And so putting pieces together really makes a difference. Okay, so basically their results said peer discussion's good, but here's what's really important, is it gave a guideline to, this kind of research gave a guideline to faculty for how we should be doing clicker questions. We shouldn't just ask a question, show an answer.
That's right.
Make them struggle. We like challenges as scientists. We do this kind of stuff all the time. So why they can fail to please, in the general scheme of things, is that if you just test factual recall, you would have all checked out. Yeah, whatever, right? It's boring. But if you give them high cognitive level questions and you have distractors that you know are misconceptions, so when I do this, I collect misconceptions and start putting them in answers, possible answers. And you want questions that can't be gamed. So it doesn't matter if you have clickers or not. Who in here has used clickers? So one person. You don't need clickers. John uses clickers too. All you need are pieces of paper. You can do 1, 2, or 3 to get a poll, this kind of stuff. Or what I have done in my class is at a table, come to a consensus, argue, vote as a table, and then hold them up, and I find that works just fine too. And then you'll see tables changing after discussion and this kind of stuff. Okay, so the point here is that active learning is engaging, it should be challenging, and it should give the learner an opportunity to express what they're thinking, either correctly or incorrectly. So these misconceptions can be addressed, and assessments, these kinds of things, help students figure out what they know and what they don't know. I saw some eyes light up after I talked about respiration. They're like, oh yeah, okay, I forgot about that part. And doing this can help construct new knowledge. If I don't address your conceptions, then you're not going to change your mind, right? And last but not least, it helps me figure out where the class is at, kind of things I've already said. These are some of the things that we've been doing this week. But you can be creative and do all kinds of different things. You maybe want to do, well, case-based studies. We've been doing that. We've been doing some technology, peer instruction, inquiry, clickers, these kinds of things. But the list is long. You shouldn't be limited. What you should be thinking about is why you're doing it, or if you should do it. So this is one slide that is condensed to say research that has shown active learning increases students' conceptual understanding versus research that has showed lecture works. Now this was an old document, and I did a report for the National Research Council, and I went through all of the literature for 10 years. And actually what I found is this. And that is a small list because that was just biological sciences. The list for physics, engineering, chemistry makes this list much, much longer. The point is that 91% of these studies I just showed you showed a positive impact for active learning. That we should be doing this in our classrooms. Okay, so recap. Students aren't empty vessels. In learner-centered classrooms, students are guided by a facilitator. And obviously, you know there are many tools for active learning. And there's evidence that we should be using this and not just talking at people. Already, I'm sensitive to the fact that I've been talking for like 5 minutes. I get nervous about that. When I catch myself after 5 or 10 minutes, I start feeling like, what have I done to my students? You have to monitor yourself. So I go a little faster, that's usually my way, or I skip things. But I at least am starting to monitor myself.